going to be similar to a circle. Remember that the circle, if it wasn't at the origin for the center, it was x minus h squared plus y minus k squared equal r squared. And so we said, what if it were this over r squared and this over r squared equal 1, which is like, you know, if you do r squared divided by r squared, it's 1, it would still be a circle. Remember, we had a problem with 4 in front of these two in an 84, and we had to divide by 4. So one example of an equation with an ellipse is if you have a different number in front of the x squared and the y squared. The 4 and the 6 could be in different places if it's horizontal or vertical. Your first step would be divide by 24, because that's the number over here, because you have to have 1 on the right. Ellipses are like an oval or an egg. They're found in many applications in science and engineering. For example, orbits of the planets of the sun are elliptical, with the sun's position at the focus. Stone and concrete bridges are often shaped as semi-elliptical arches. Elliptical gears are used in machinery when a variable rate of motion is required. Ellipses also have an interesting reflection property. Recall that an ellipse is created when the plane is slanted across only one nap. So remember, if you had a cone and then another one, and if it were, I think it's like cut this way, that it would be parallel to that one. And your definition was the collection or locus of all the points whose sum from two fixed points called the foci is constant. Some people say foci, some people foci, so you may hear it either way. It basically looks like a stretched out or flattened circle. So say you have this. If it's stretched out more like that, that's going to be an ellipse. The line containing the foci is called the major axis. The midpoint is the center of the ellipse, just like there was a center of the circle. The one perpendicular is called the minor axis, and the intersection between the ellipse and the major are called the vertices. The distance from one vertex to the other is called the length of the major axis, and it is symmetric with respect to the major axis, the minor axis, and to the center. The major axis contains 5 points or ordered pairs. The minor contains 2 from the distance b. Remember that on ellipses, the variable a relates to the major axis and c relates to focus. So a is for the major axis and c for the focus. So your objectives are to analyze ellipses with center at the origin or at HK and solve applied problems. So with analyzing them at the origin with center 0, 0 along the x-axis, so kind of like this idea, like a track. Your equation of the ellipse with the foci at plus and minus c0 and vertices at plus or minus a0 is the following. So basically you're going to have A here, you're going to have negative A here. Pretty sure C is on the inside, like that. And positive B would be here, negative B would be down there. So basically you would have x squared over a squared plus y squared over b squared equal 1, where a is bigger than b, which is bigger than 0. And that means you kind of have this thing looking like the Pythagorean theorem, but a squared is biggest. So b squared plus c squared. So the major axis is horizontal. Notice a squared is on the left in the formula. Now for the y-axis, it's like this. So a is here, negative a is here, b is here, negative b is here, c is here, and negative c is there. And again, your center, I guess if you want a capital C, it's right there at 0, 0. So the thing to notice is that A is biggest and it's underneath y squared since it's vertical. So that's the main difference. So on this one, A is biggest and it's underneath x squared since it's horizontal. So that had to do with this figure. A was biggest and it's underneath x squared since it's horizontal. And this was the vertical one. Now, like the other type figures, you could have a random ordered pair like HK. Think of this as X and this as Y, but we can't use those letters because they're already reserved. So remember, if it's X minus H, that means right. So your foci are H plus and minus C with K, and your vertices are H plus or minus A with K. That's when it's parallel to the x-axis. So for example, like that sort of, I didn't make it perfect. So that's your formula. When it's parallel to the y-axis, could look like that. Again, your positive A would be up here, negative A to here, B, negative B, C, negative C. And this is H comma K. I guess I didn't label a few of those points on the last one, or any, but I think you get the idea. Center, A, negative A, B, negative B. That center is H comma K. And you have little c here and negative c there. So your y values all match up. Y values of A and C match, because they're all the same height. And on this one, your x values of A and C match. So kind of like on parabolas, there are lots of formulas. Things to remember about ellipses: the variable a squared can go under the left or the right. Whichever one that it's underneath tells you if it's horizontal or vertical. X squared or the x minus h squared is always first regardless. Of whether it's horizontal or vertical. A is always bigger than B on ellipses, and so you can use the modified Pythagorean theorem like that. Sometimes you're given A and B, and so it's easy to write the equation in graph. However, you need C for the focus, which is in between the center and the vertex. So remember the vertices are on the outside. A, B, and C should be positive since they're lengths. Don't forget the center as the offset when you're not at the origin. It's always plus or minus the same length, not plus or minus the same number, unless you're the origin. Length, not origin, or length, not number. And then your type of problems are finding an equation, graphing by hand, or the calculator. Analyzing the equation, which means find your center, major, foci, vertices, and graph it. So lots of parts to the analyzing. Finding an equation when the center's not at the origin. Graphing by hand or utility when it's not at the origin. Analyzing which was harder, like involving completing the square and solving a lot applied problems. So just as a reminder, on these, if you want to, you can go to graphs and go to graph entry and equation templates, and this would be for the ellipse, and it tells you the form. Now, like we discovered on the last lesson, if you would have rather just gone to like there, press delete and go to relation, you could type whatever you want. So remember, you could have done like x minus 3 squared equal 16y. That was your parabola, and you could still do your analyze graph, analyze conics to get your foci and whatever you needed. And then your directrix would be down here. So, like I said in class, if I had to do it over again, I'd probably just use relation instead of having to solve for y where it's 16 underneath. Now, what y'all are doing now is with ellipses. So that was just a quick little review. So your first one is a definition. The foci lie along the major axis. Now this one, what's going to jump out at you is you got to do the square root of 4 is 2, and the square root of 25 is 5. Since 5 is bigger than 2, A is 5, and B is 2. And that means this is going to be vertical. And so since it's vertical, your vertices would be, oh, and also there's no extra minus or plus up here. Your center is at the origin, and so you basically are at 0, 0, and you go up 5 and down 5. And so that's why it's the ones with the 5s, with x being 0. So this was vertical, so x was 0, because it went through the origin. Sometimes it would be x equal h, whatever that number is. But in this case, it's x equals 0. Now on this one, you'd notice A would be 5 and B is 3. Because the whole point of these is do your square root. Okay, so this is going to be horizontal. And again, your center is going to be at 0, 0. And so A is 5, that's this one. B is 3, that's this one. And it's the x-axis, because again, we're horizontal. It's not an exact circle. And so the major is this way, the minor is this way. Compare that to this one where your major is this one and your minor is this one. Now this one says your center is at 3, -4, so you might want to plot that. And on this one it says the major is parallel to the x-axis. Well, this is x, this is y. So this is going to be a horizontal. Use your clues, because sometimes they may change it to y-axis. The distance from the center to the vertices is 5 units. So if we start at 3, -4, this point over here would be 3 plus 5, comma -4, which is 8, -4. 4, 5, 6, 7, 8. So there's your vertice. And then this one, you've got to go 3 minus 5, comma -4. So that's -2, -4. So this is your vertice. And that's what we got. So you didn't have to do any extra steps other than that. Now on this one, 36 is bigger than 25, and so A is 6 and B is 5. You really got to know your square roots. It's going to save you so much time. Remember, if you have to, do y equal x squared and then make a table 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100. That's just going to help you if you have those memorized. So based on the 36 being underneath the x squared, that means it's going to be horizontal. Remember, it's equal to 1. And so since your center is at the origin, then we could plot it, go 6 units this way. There's a vertex at 6, 0. 1, 2, 3, 4, 5, 6. Here at -6, 0. We also know B is 5. So 1, 2, 3, 4, 5. That's 0, 5. That's B. You know. And then 1, 2, 3, 4, 5, 0, -5. Now, what we don't know is exactly where to place C. But you have that formula that we talked about. It's like the Pythagorean theorem. And so we'd say 36 equal 25. So remember, A squared would be what's underneath, and B squared would be what's underneath, plus C squared. So then just subtract 25, and you get 11 is C squared. So C is plus or minus the square root of 11. Now, if you want to estimate that, square root of 9 is 3, square root of 16 is 4, So square root of 11 is somewhere around there. I would estimate it as 3.3. Let's see if that's about right. Could be 3.2. You know what? Sometimes I surprise myself. Okay, so there you go. That's about 3 1/3. Not exactly, but 1, 2, 3, and a little bit. So that's square root of 11. And 1, 2, 3, and a little bit. That's negative square root of 11. So that's your positive and negative square root of 11, comma 0. And so then we can draw this. Oops, I messed up on my drawing. I am not an artist. Okay, so then now we know it's not vertical. And here's my kind of like, sort of like, I don't know, best guess type thing. Since 6 and 5 are close, the ellipse is almost, not quite, a circle. This one's too wide. That one's just right. That's how I do it. Test it, try it, learn it. Okay, so on this one we have 64 under the y squared, and so that means a is 8, b is 5, and this is vertical, and it goes through 0, 0. And so 8, negative 8, 5, negative 5. Your vertices are here at the 8 and at the negative 8. Now, because it's a vertical line, you know, going through the origin, that's really 0, 8. And this is 0, negative 8. So that's what we want for this. And then for this, we want 5, 0 and negative 5, 0. Now, we need to get the foci, and so we say a squared equal b squared plus c squared. A squared we already know is 64. And b squared we already know is 25. So we don't have to go through the same process. Well, what was 8 squared? We already know it's 64. What was 5 squared? We already know it's 25. What we do have to do is 64 minus 25. Good old-fashioned 39. So c squared is 39, so c is plus or minus the square root of 39. And that's not divisible by 4, 9, 16. So it's already reduced. So that means you have your C values here. So plus and minus square root of 39. And then that'd be this one. They actually label the numbers, which is useful. This one's horizontal, that one's horizontal. And here, they used the foci answer, which was over here. Here they used the B answer. Remember we said b squared is 25, well b is 5. Okay, and then on this one, they're telling you a little bit more information. Center at 0, 0, focus at 16, which is pretty far out, because that means the vertice has to be somewhere out beyond it. I'm going to say vertex. Okay, and then now one of them says negative 20. Well, they're just kind of like messing with you a bit. It is all symmetric, like we said. So if this one's 16, comma 0, this one's negative 16, comma 0. And they're telling you negative 20, 0. And so the other one is positive 20, 0. And we don't know like how far up it goes. But what we do is a squared equal b squared plus c squared. And we know that c is this distance, which is 16 squared then, because we need c squared. A is this distance, which is 20. And don't just guess 4, because it doesn't work like that. So this one would be 400, and this one 16 squared. Oops. So 16 squared is 256. Then 400 minus 256 is 144. And so b is the square root of 144, which is 12. Now, because it is horizontal, well, let me go ahead and graph it. Like the 12 goes up here, shorter than the 16. And then 0, negative 12. Okay, so it's not vertical, and what I was saying was a squared was 20 squared, which is 400, and this is b squared, which was, 144, because b was 12. So now, I would think if they gave you 24 and this is halfway, so that's 12. This one, I think 4, 8, 12, 16, 20, 24. So this is counting by 4s, 4, 8, 12. So that's your answer. That's probably a good stopping point for that video because it's already about 30 minutes. Hope that helps.